Hello everyone. So today I'm going to discuss class 11 chemistry. That is, what is the difference between empirical formula and molecular formula, and how to solve the questions which are related to empirical formula. Okay. So before going to start the numerical, so let me explain what is a molecular formula and what is an empirical formula. Okay, so first let me discuss what is a molecular formula. Molecular formula, it is nothing but it is the chemical formula. It is the chemical formula which represent the actual number of atoms of each element present in a molecule of the compound. For example, so if I write an example here, C6H12O6. So it is a molecular formula of glucose. It indicates what here? It is the molecular formula of glucose. It indicates it's a chemical formula which represent the actual number of atoms. Actual number of atoms means in the glucose molecule there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Then what is the empirical formula? Molecular formula is C6H12O6. Then what is empirical formula? How do you define empirical formula? See, empirical formula, it is nothing but, see, it is the formula of the compound. It is the formula of any compound, okay, which shows the simplest whole number ratio between the atoms of the elements in the compound. So just now I have written molecular formula of glucose as C6H12O6. So this is glucose molecular formula written. Then from the molecular formula, how to write the empirical formula? So what it says here? It shows the simplest whole number ratio between the atoms. See, if I take here the ratio of this one, if I take here, it comes out to be 1:2:1. It indicates what here? So my empirical formula now, empirical formula. So what we can write here? So that is one carbon atom. Okay. So this is one carbon atom and two hydrogen atoms, and oxygen is one. So this is your empirical formula for the glucose molecule. Okay, so then how to solve the questions related to the if it is given molecular formula and empirical formula, what is the how to solve the empirical formula and molecular formula related questions. See, whenever a question is given to write the empirical formula and molecular formula, basically, so what we'll have to do here it is, so you need to draw a tabular column like this. So in this, in the first column you have to mention element. First column you have to mention element. Next, the percentage composition. In the question it will be given atomic weight and relative number of atoms, and it's the simplest whole ratio of whole numbers. Okay, so first of all, before solving any question, you need to remember certain formulas. What is that formula here? See, what are the first formula is, so for example, if you want to calculate the molecular formula of any compound, okay. So what is the relation between empirical formula and molecular formula? So I am going to give the two important formulas here. So what is that? The first one is molecular formula. Molecular formula is equals to, you will be writing it as empirical formula. Empirical formula into, you have to multiply by n. So you may ask, what is n value here? N is a whole number here. How to calculate? Okay, so molecular formula you understood. What is empirical formula you understood. Then what is n here? How to calculate n? So to calculate the n, so what you have to do is, so there is another way of expressing the n value here. So N will be calculated by molecular weight. Suppose in the question they will give you the molecular weight for a given compound. They will be giving molecular weight, and if after calculation you can also write here empirical formula weight. Okay. Sometimes in the question they may not give you the molecular formula directly. Okay, so in that particular case, what we'll have to do? So they will give you the vapor density value. If they are going to give the vapor density value, so you have to multiply 2 with the vapor density value. It is a vapor density value upon, you can write it down, empirical formula weight. Empirical formula weight. So these are the two formulas you need to remember. One is molecular formula is equals to empirical formula into N. And another formula how to calculate the N value, that is N is equals to molecular weight upon empirical formula weight is equals to, okay, if it is a molecular weight directly it is not given. So in this particular case you have to write 2 into vapor density. Sometimes the vapor density value is given 2 into vapor density upon empirical formula weight. Okay, so let me explain with the question. See my dear students, so one question I have given, we have given here a compound of carbon, hydrogen and oxygen. Okay, the compound of carbon, hydrogen and oxygen is given, is found to contain, okay, 40% of carbon and 6.7% of hydrogen and 53.3% of oxygen is given. Okay, so basically in the question they will give you the percentage compositions. So what is asking here? Calculate its empirical formula. Okay, so here, and one more thing, what is the data is given here? Its vapor density is given. Okay, what is the vapor density here? 30. Okay, what is asking? Not only to calculate empirical formula, so they're asking you to calculate the molecular formula as well. Okay, so then what is the procedure to calculate the empirical formula, right? Molecular formula. See now here, so you can see the tabular column here. See in the first column what I have mentioned here, it is element. The next in the second column you may write it here percentage composition, and the third column atomic weight, and the fourth column is relative number of atom, that is atomic ratio, and the fourth column is simplest ratio of whole numbers. Okay, so the first thing what you'll have to do here, it is given a compound contain carbon, hydrogen and oxygen. So what are the elements it is given? So that is one is carbon, hydrogen, next one what you are having, oxygen. Okay, in the first column I mentioned whatever the elements is given. Next it is percentage composition is given. So carbon composition, how much it is given? That is 40%, and the hydrogen it is given 6.7%. Next oxygen it is given 53.3% it is given. So I have mentioned all the given compositions. Next let me write atomic weight. Atomic weight also it is given, atomic mass, that is carbon is 12, hydrogen is 1 and oxygen is 16. Next thing what we'll have to do here, see you have to find out the relative number of atoms, that is atomic ratio. First what you'll have to do, whatever the percentage composition it is given, you have to divide with the atomic mass or atomic weight. So what is that here? 40 divided by 12. So next 6.7 by, it is atomic mass of hydrogen is 1. Next oxygen, how much it is given? That is 50% composition is 53.3 divided by 16. So if I find out these values, so here 40 by 12 it is comes out to be 3.33, and here it is 6.7, and next 53 point. So it is approximately you are going to get the value as 3.33 only. So after writing the atomic ratio, whatever you got the values related to number of atoms, next thing is you have to find out the simplest ratio of whole numbers. How it is going to be? First check whatever the value you are getting here, whichever is the least value. First I'll see out of these three values, whichever the least value here, that is 3.3. Both the cases it is 3.33 it is. So now what I'm going to do here, whatever the relative number of atoms value I got it here, I'm writing 3.33. Okay, to that value, I'm going to divide with the least number value. So that is 3.33. So I'm writing here dividing 3.33, and again 6.7 upon, that is 3.33, and here also 3.3 upon 3.3. So what is the value I'm going to get here? That is 1. Here it is comes out to be the value, approximate value I'm writing here, that is 2, and next that is 1 here. So it means here the approx value I have written, that is 2. Okay, if it is getting, you are getting 1.5, it is greater than 1.5, the nearest value you can take, or if it is less than 1.5, you can take it as 1 only. Okay, so now see the empirical formula. Okay, see here, now we got here simple ratio of whole numbers, right? So the simple ratio of whole numbers, so with respect to carbon it is, what is the empirical formula now, what we can write? So empirical formula, now we can write here, that is number of carbon atoms is 1 and hydrogen is 2 and oxygen is 1. So this is your empirical formula. Now I'm going to find out the empirical formula weight also. So empirical formula weight. So how many carbon atoms we have? 1 carbon atom, right? So that is what we can write here. The atomic mass is 1 into 12 plus 2 hydrogen atoms, 2 into 1 plus 1 oxygen atom, that is 16. So what is the, so 12 plus 2 plus 16, how much it is going to be? So it is going to be, it is 30. So empirical formula weight is 30 here. Now what, so we have what we, first thing, what is the empirical formula they have asked? So we have written the empirical formula. The next one more thing, what is asking, to calculate the molecular formula also. Okay, but to calculate the molecular formula, what is the formula I have given? Empirical formula into n I have given. Okay, but we know the empirical formula, but we don't know the n value. First we'll have to find out the n value. So to calculate the n value, what is the other formula I have given? So that is if it is directly molecular weight, is there any molecular weight is given? Not given. So vapor density is given here. Here it is given vapor density. So what is the formula to calculate n? That is n is equals to 2 into vapor density upon empirical formula weight. Empirical formula weight. So what you are going to get here, empirical formula weight, how much it is given? It is given 30, right? So n is equals to 2 into 30 upon, and empirical formula weight, how much we got it here? Empirical formula weight also we got it as 30. So what I'm going to get here, 30 get cancelled, our n value is 2. So n value we got it as 2 here. Okay. So you got the n value and you know the empirical formula. With that we can find out molecular formula, right? So what I'm going to do here, molecular formula is equals to, what is that? Empirical formula So multiplied by n value. Okay, so what is your empirical formula? That is CH2O. So if I multiply by 2, so what I'm going to get here, that is C2H4O2. C2H4O2. So this is your molecular formula. Okay, see, my dear students, this is how you need to solve the question. Once again, I repeat, whenever the question is given like this, okay, first thing, you have to write in the tabular column elements first, then percentage composition, whatever it is given, then write down their atomic weights. After that, what you'll have to do? You have to divide percentage composition upon its atomic weight. Percentage is composition upon atomic weight. So that you are going to get the atomic ratios like this. After that, to find the simplest ratio of whole numbers, so what you have to do? Whatever the ratios you are getting here, okay, from that the least value, here the least value is 3.33, right? So what I have done, whatever the value I got it as atomic ratio, to that, with the smaller value I divided, then I got these values. So from whatever the simplest whole number ratio I got, so with that I can write here empirical formula. So once I got the empirical formula, then what I have done, see, empirical formula weight also have calculated. So empirical formula weight I got it here, it has 30. Why? Because he is asking not only empirical formula, so they have also asked to calculate write down the molecular formula. To write the molecular formula, so what they have done, directly not given the molecular weight, but they have given the vapor density value. So if it is vapor density value is given, I have given one more formula. It is N is the whole number. That is N is equals to 2 into vapor density upon empirical formula weight it is. Okay. So what I have done, 2 into vapor density value 30 is given upon 30. Then the N value I got it as 30. So the next what I have done, a molecular formula is equals to empirical formula into N. So empirical formula what we got here, CH2O. I multiplied with the 2. So that will become C2H4O2. So this is how, my dear students, you need to solve the question which are related to the empirical formula, right? Molecular formula. Hope, my dear student, I think you understood the concept. So if you like this video, please like my video and subscribe my channel. Thank you and love.